Hello, class 11. Welcome. Chemistry with Qureshi sir. Structure of atom. The section is photoelectric effect. Very important. It was propounded by a German chemist known as Heinrich Hertz in the year 1887. What does his photoelectric effect stated that when a beam of light, photons, is incident on a metal surface, electrons are ejected from it. This phenomena is known as photoelectric effect, and the ejected electrons taken out from the metal surface is known as photoelectrons. Now we will understand all the experiments and observations from this particular experiment diagram. See, first of all, he took one metal plate, let's say potassium, sodium, or some other metal. He passed a sunlight. A sunlight is nothing but a beam of light which is consisting of the discrete particles called the photons of massless particles. Photons are massless particles. So this sunlight is focused on the metal surface. Electrons are ejected from the metal surface and go to the detector, and there the function of the detector or the work of the detector is to count the number of electrons which has been ejected out from the metal surface. Number one, there should not be any time lag or time gap. Means this incident beam of light, when it's falling on the metal surface and the ejected out electrons, is a continuous process. It's a continuous process. That's it. There should be no gap or no time gap or no time lag. Now number two, the more the frequency of the incident beam of light, means photon, striking on the metal plate, the more the number of electron will be ejected out and goes to the detector screen. Got? Second point. Now, every electron on the metal plate is having a threshold frequency, means minimum frequency required for an electron of a metal to get ejected out. So always the frequency of the incident ray, that is the sunlight, has to be larger as comparison to the threshold frequency of the metal, of the electron present in the metal. So there the electron will successfully get ejected out and goes to the detector screen. Number 4, if the incident beam of light frequency is lower as comparison to the threshold frequency of the electron of the metal, then the electron will not be ejected out or coming out from the metal. Okay, got this point? Okay, very good. Now we'll come to the, it is so happen what we have learned, the incident beam of light should be having more frequency as comparison to the threshold frequency of the ejected electrons. The extra frequency which is left behind after ejecting out the electrons, it will be converted to the kinetic energy of the ejected electrons. Got? So always the frequency of the beam of light or the incident light has to be more than the threshold frequency of the electron to be ejected out. If this is not made, then the electron from the metal surface will not be ejected out. Finish. Now let's see. What does the frequency terms? Frequency is used for the color of a different color. Frequency is varies with the color. And intensity is nothing but the brightness of a beam of light. And frequency is nothing but referring to the color of the incident photons beam. Now let's come to this particular example. We take a potassium metal whose threshold frequency of the electron is how much? 5 into 10 to the power 14 Hertz. Suppose incident beam of light, which is nothing but red color, it is having how much frequency? 4.3 to 4.4 into 10 to the power 14 Hertz. Means here you see threshold frequency of the electron is more as comparison to the incident beam light frequency. So in that perspective, if the threshold frequency is more than the frequency of the incident beam, ejection of electron will not take place at all. Now, coming back to here. If the incident beam consisting of the yellow color, which is having a frequency of how much? 5.1 into 5.1 to 5.2 into 10 to the power 14 hertz. Now, this is more than the threshold frequency of the electron present in the metal. So, if this incident be having more frequency as comparison to the threshold frequency of the electron present in the metal, then the ejection will take out. Then the electron will take out successfully from the metal and go to the detector screen, and there the number of ejected electron will be counted successfully. Now please do for me one favor. I will bring the notes for you. You just copy it, pause and copy it. Very simple for you. I have given a proper explanation. I hope so. Pause it and just copy it. Yeah, pause it. Just copy it. Pause it. Yeah, take the photo clip also. Now let's come back to here. Come back to here. I think it will be okay. Now here, first portion means the extra frequency which is being unutilized, it is going to convert it to the kinetic energy of the ejected electrons. So incident beam frequency has always to be maximum to the threshold frequency of the electron probe present in the metal. Now you just take the photo clip or pause and just copy it. Now pause and copy it. Frequency is nothing but it refers to the color. The intensity of the incident ray, it refers to the brightness. Now you take this example very well. This belongs to the potassium metal. Now you take this one also, clip also. I hope it is well understood. Subscribe my channel, press the like button and pass your comments. Okay, thank you.